Hello. Can you guys all hear me if I stand here? Cool. Great. I'm Alex. It's a really good introduction, but like I said, I'm a senior developer at IG, and today I'm going to talk to you about how we've used Microfrontends at IG to just improve developer experience and, as a result, client experience. So I get it, it's the end of the day, and you're thinking, why is this guy waffling on, talking to me? So I want to start by answering the question of why you should care about this talk. So at IG, we started to see a reduction in lead time for feature delivery, improved performance, and that's both technical performance metrics and also team performance, that kind of reduced lead time. And we're seeing lots of those benefits as a result of giving teams more autonomy to deliver features in their own way and whatever works best for them. So now you're obviously excited. The talk itself is split into kind of three parts. I'm going to give a little bit of a background about IG itself. I'm going to spend the bulk of the talk talking about the technology itself, some of the architectural decisions we've made. And then I'm going to finish off by just talking about a bit more about kind of the improvements we've been seeing. So I thought before I dive too far into it, and obviously we've already had 2 talks on Microfrontends, so I won't spend too long on this, but I really like this description from Cam Jackson. So Microfrontends is an architectural style where independently deliverable front-end applications are composed into a greater whole. So you're taking a bunch of smaller apps and composing them in a way that clients at the end experience them as one application. So without further ado, let's get into the bit about IG. So IG is a financial services fintech based in London. And our bread and butter is producing trading platforms like this one you can see on the right-hand side of the screen right now. And this trading platform you can see on the right-hand side is what we've been starting to unpick and pull out and divide into independently deployable microfrontends. And you can see that it's got this really nice paneled, separate UI kind of structure, which makes it a really good candidate for splitting out into separate sections. So IG's web trading platform is not new. It's, I guess, 6 or 7 years old now. And it started as a set of separate repositories that were linked together with NPM and came together to produce the web trading platform. So the issue with this is great. We had lots of advantages of that. We had a really nice explicit dependency tree, but we also had some challenges, namely that the way we split up this technology meant that if you wanted to deliver a feature, you'd be raising multiple pull requests and getting them merged and updating. That's probably quite a familiar story. So what we decided to do is take all this code and put it into a monolithic application. So as I say, had the benefits that we only had to raise 1 pull request, which was great. But as the application grew, we started to fall foul of some of the typical challenges you get with big monolithic applications. Our build time started to go up, and we started to end up with these quite complicated sort of implicit dependency trees where we didn't know what was going on and started to end up with a little bit of a code soup. So it's starting to feel a little bit Goldilocks-y. We had sort of too hot, too cold, and we were looking for the perfect bowl of like proverbial porridge. So what we did was move this monolithic application and start to migrate it to a mono repo. So this was great because we had some of the advantages of our separated code base and some of the advantages of our monolithic code base. So we had explicit dependencies again. We had technology freedom, so any of our packages could be in any framework we wanted. We still only had that single PR per feature. That was a real benefit of the monolith. And by having these packages again, we can have kind of a natural separation of concerns. We did have one sort of big outstanding thing that was kind of not perfect with this model, and that was a bottleneck with this platform release. And this was fine when we only had kind of a single team working on the application. That could be managed and people could go into sort of a release queue. But as we started to, as you'll see, we started to move towards a multi-team model, and this becomes a bigger problem. And with that, I just want to take a little tangent to talk about team structure IG, because it's really an important backdrop to why we're introducing this micro-front-end architecture. So IG's traditionally had kind of a horizontal team structure, and by that, if you view your stack as being vertical front to back. Our teams tend to be split across technologies. So you can see on the diagram here, you can see our front end, which is kind of our three parts of our monolithic front end in red. It's responsible, our web platform team is responsible for that. And then we have a collection of middleware, API teams, data teams, and a collection of other sort of back-end teams responsible for other services in IG that keep that web trading platform up and running. So some really good advantages of this. We had really strong ownership of code bases. So people tend to work on a single or a few small code bases. And we had really strong tribes of specialists. So, you know, if you were a front ender, you'd work with all of the other front enders on this web platform team. So that's great. But it came with some challenges. Features require a lot of cross-team communication. If I had a feature that spanned the full stack, you can see from this diagram that you've got at least 3 teams, even if it's a really simple example. And as a result of that, the architecture that we produced to solve problems often reflected teams that are geographically or culturally close to each other rather than probably the right solution to the problem. So in order to help try and mitigate these problems, we've started to move towards a vertical product team model aligned to kind of journeys or business domains. And we got some great advantages of this. So as a result, we're having much reduced cross-team collaboration and much better team autonomy. So teams could own a feature from front to back and own the full delivery of that feature. But you can still see here the boxes I've got in red represent the sort of front-end application. And that bottleneck of that front-end release is now starting to become a really big problem because these teams now can make changes across their full stack except for their front end, where they've got to join a big release queue and wait until someone decides that it's ready for this web trading platform to be released. So how do we solve this? I'm sure you'll be unsurprised when I say it's Microfrontends. But let's talk technology. So our tech stack for this, we're using single SPA as kind of as a framework to help provide and manage our kind of interfaces and our APIs between our microfrontends and our host application. Using SystemJS to orchestrate and manage our modules along with import maps. We use a CI, I've put CI tool here. We use a combination of Jenkins, Bamboo, and GitLab. But this is basically to manage kind of import map orchestration. So there's a shared kind of JSON file that provides a link between the host application and the micro front ends. And there's some challenges around concurrency and how that shared resource is orchestrated. And I'll go on in a bit more detail to talk about that. These certainly aren't the only ways you can solve micro front end problems. So good old fashioned iframes are a great solution if you just want to be able to have separate applications really quickly. SystemJS has a great alternative in the form of Webpack module federation. And our kind of custom CI tool, there's an alternative that single SPA produces called import map deployer, which does many of the same things that our sort of CI solution does. So going on to talk about a little bit about our architecture. So I'm going to use these 3 fake teams in my example, and on the right-hand side, this kind of fake web application. So we have our host team responsible for our platform itself, and we've got our blue team, which is responsible for these 2 blue micro front ends, and then our red team responsible for that red micro front end. So obviously we've got these separate teams, we've got these separate applications, but we need a way for them to be able to link together so that ultimately they can all be rendered on that host application, that host platform. And the way we do that is by having a shared resource that sits in the host team's remit called import maps. So as you can imagine, with the exception of the import maps themselves, all of our applications have a fairly standard sort of CI/CD process. So they go through tests and security gating and linting, etc. And once we're happy with that, we deploy them, in our case, to AWS S3. But we still need a way for our micro front-end teams to tell our import map repository that there's been an update. And the way we do that is by having a separate CI box that runs and is attached to the import map repository, running a tool that we've simply named import map updater. And this is kind of IG's secret sauce when it comes to our kind of micro front end architecture, our kind of solution. So the way this works is that when our micro front end teams update one of their applications, they also trigger an update to this CI box with some config, which represents kind of the change they're going to make. And this computes what the new import map should look like. It uploads that to S3, and it also commits it back to the import map repository so that the next team that does it gets an updated thing. And this also manages kind of concurrency and makes sure that we're never trying to update the import map from multiple places at once. So I've talked quite a lot and I've shown quite a lot of diagrams. So I'm going to dive into a little bit of code and hopefully that'll help illuminate anything that's not clear as of yet. So I'm hoping this is going to, I might just have to drag this across. Okay, that's cool. I'll drag this across and I'll drag across the other. Oh no, that's there. Okay, great. Cool. Bear with me because I'm going to have to try and type this without being able to see two screens. So is this big enough? Can you guys see this? Yeah, all good? Great. Cool. So I've got a big speaker in front of me here, so I'll try my best to see this screen here. I will start. So let's start with the. I'm gonna move around here, I think. Let's start. So starting with kind of the folder structure. I'm using Turbo Repo for this, which is a little plug for. I hadn't used it before this, and it's awesome. But I've essentially got multiple different teams here. So we've got our blue team, and inside that they're responsible for our Navy micro front end and our Sky micro front end. We've got a host team, which is responsible for our host, that kind of platform application, and our shared import map codebase. We've got our red team, which is responsible for our maroon micro front end. And then we've got our sort of secret sauce, that import map updater. So before I go too much into making some changes, which we will do, I just want to show you how this import map shared repository kind of works. So as I said, it's just a glorified JSON. It's just key value pairs. That's what the import map is. So here we've got a single import map called app.json, and this is what is used by default. So if a user visits our app in production, this is the import map that will be loaded, and whatever the versions of the micro front ends that are in here, that's what will be loaded in our production application. We also have the ability to create sort of pre-release import maps to allow teams to test their changes in situ in the host application prior to them being live to any clients, and we'll show that as well. So the way this works is this package depends on our import map updater, and it just exposes a few commands, so a release command and a pre-release command, and it provides just a link to that kind of production import map, which is kind of our source of truth for where the code sits. So before I go into the actual live coding, there's one more bit of this import map update I want to show you. So I've already shown you this release and pre-release. I just want to show you this trigger command. So this is a tool to enable micro front-end teams to more easily trigger updates. In this case, it's fairly trivial. It runs a command in a particular workspace. In this slightly contrived demo, that's all it does. In our actual case, it triggers a remote build via REST API and manages things like authentication, all that sort of stuff for you. So let's go and actually make some changes to these code bases. I will. God, I can hardly see what this says. Okay. Can you guys can all see this? Fine. Obviously my site's just awful. What do I want here? So, our Navy micro front end. So I'm going to show you the actual application, which is here. It's fairly uninspired at the moment, but hopefully it'll give you a good example of what's going on. And we're going to make changes to this Navy micro front end here. So in our Navy micro front end, we've got a few different things we want to look at. We've got two entry points here. We've got a Navy Microfrontend and we've got a beta version. And I've written these two entry points to essentially expose these two different root components. And for the sake of the demo, this represents kind of checking out a new branch and making changes on that branch will be this changes to this beta component, and then you can think of changes to this core root component as what would happen when you merge back to the trunk and kind of apply it to our master branch. So the first thing I'm going to do is make changes on a feature branch. So let's just make an update here. So if I save that, we'll get no changes immediately. But what we can then do is we can then run a pre-release command to test those changes in situ in the host application as if we were clients. So the way I do that is I can just run yarn run post version. Gonna hope I can remember all my commands off by heart. That's pretty good. So all that does is just run this pre-release TypeScript file. And all that does is compute sort of a key value pair of change things and call that trigger pre-release function I showed you from the import map updater before. And hopefully if it's all worked well, where am I? Successfully, oh, sorry, I'm running the wrong thing. That's fine. I'm gonna run yarn run pre-release. That's fine. So, sorry, I was supposed to run yarn run pre-release, which runs that pre-release step. And what we see here is a new microfrontend, a new import map being produced. And you should be able to see here, this Navy microfrontend now references MFE beta. So if I go back into our application and add a query param to our application, I think I do this, yeah. So you can see that we can use a query param to test our change in situ in the application. You can run automated tests against this, however you want to verify your changes prior to it ever being live in production to any actual clients. So going back, if we're happy with this change, we can then go and apply that change to our to our master branch. We can merge it into our trunk. So that's what I'm going to do. I'm going to copy this and I'm going to quote unquote merge it. And when we merge our changes, what we're going to want to do after that is tag our code base and release it. So that's exactly what we'll do. We'll do yarn version minor. So hopefully that should do that, and we should get a new we'll get a new release as well. So hopefully I'm depending on the version in my Webpack config, hence the not hot reload. So if I have a look at my app now, we should be able to see that our Navy microfrontend is now version 1.8.0, whereas previously it was 1.7.0. So we've tagged the version and we've now updated that production import map. And so when we go back to our application, you'll see that because I've stopped serving the 1.7.0, it's no longer working. Right. I actually can't read this. Can someone tell me where when I hit the end of the localhost? Keep going. Keep going. One more. Yeah? Okay. Okay, great. Cool. See, we love a bit of audience participation. Okay, so now you can see here that we've got our Navy microfrontend and we've got our update applied and we're now on version 1.8.0, which is awesome. So I want to show you one more thing before I stop demoing and go back to some slides. So compared to the example on the slides, you can probably see that there's a big gap on the top right of the web page here. That's because we're missing our kind of Sky micro front end. So let's go ahead and show you the process of actually adding a new micro front end, because it's also a fairly straightforward process. So what I'll do now is I'll cd into our Sky micro front end, and our Sky micro front end has pretty much exactly the same structure as our Navy micro front end. It's still got the same 2 steps. Now, when you're introducing a new micro front end, you can update your production import map without any worry, and that's part of what our kind of import map updater gives us, is that we're safe in the knowledge that we've not got any human error associated with our import map updates, and we know they're safe and they're only ever going to add things. And if you're adding a currently not used micro front end, it's not going to make any changes to the app. So that's exactly what I'm going to do now. So now that's done, you should be able to see in our production import map, you can see this Sky micro front end has now found its way in. But if we go to our actual web page, you can see that's still not live to anyone. And this is because we need to make one change to our host application just to recognize where we're actually going to render it. So let's do that. So in our host application, we need to first register our micro front end, and this just uses register application from single SPA, and we just need to make sure we name it and we tell it where to import from, which in our case is the same name, which is great. And then the last thing we need to do is tell it where to render. And one of the ways we can do that is by providing this very specific ID called single SPA application. And we just need to provide the name of the micro front end. In our case, Sky micro front end. So if we dive back to the application now and do a little refresh, you should see our Sky micro front end has come in and loaded. And now it's loaded into the application. We can go through the same process that we would have done with the Navy micro front end and do updates however many times we want without ever touching the host application. So diving back to the slides, I've talked kind of very positively, and Ruben's covered this a lot more detail than I will, but I want to just answer the question of should I use micro front ends? And this is by no means an exhaustive list of questions, but hopefully it's a good starting point for understanding whether or not it's appropriate to use micro front ends in your organization or in your applications. So starting off, is your application sufficiently large? There's no hard and fast rule for this, but do you think you have a big code base? If the answer is no, then you probably don't want to be using micro front ends. They're probably not the right thing for you. If the answer is yes, there's 2 more questions I want you to ask yourselves. Do you have multiple teams contributing? And do you want to incrementally adopt a new technology? If the answer to both of those questions is no, then again, micro front ends probably aren't the right thing to you. But if you answer yes to one of those questions and your application is sufficiently large, then micro front ends might be something you want to consider as a potential solution for your use cases. And if you do decide to use micro front ends, choosing a good micro front end candidate is kind of the $1 million question. If you get this wrong, you'll have all the organizational and technical overhead with none of the benefits. And we at IG are still learning how to do this, but we've developed a few rules of thumb on what makes a good micro front end candidate. So firstly, make sure you split up by domain, and I'm pretty sure Ruben already covered this, but make sure you're trying to split up by business domain, a business journey, think login or depositing money, something that a user can do and you can deliver complete features within. Secondly, don't pick components that are too small, things like button groups and tabs and lists. On their own are much more appropriate to be in a shared component library, and actually, a shared design system is actually really valuable for micro front end architecture anyway. And thirdly, don't pick things that depend on a lot of context. If you're providing huge amounts of contextual information to your micro front end, odds are it's either too small and it should encapsulate that contextual information, or it may be that it's just not appropriate to be a micro front end because it's so specific to that particular use case. So jumping back to IG's web trading platform, I want to just square a few places that are good and a few places that are bad micro front ends. So this help and support panel, this is a good micro front end. It's the sort of thing that represents a specific user journey, a domain. It can load its own data. It's not too small, and it doesn't depend on an awful lot of contextual information. Similarly, this popular markets list is kind of a list of data that can load its own data. And again, it's not too small. It doesn't depend on a lot of context. Conversely, these little group of tabs in the top right, they're just way too small and just are not appropriate to be a micro front end. And perhaps slightly more controversially, this panel on the left-hand side, in our use case, just isn't appropriate micro front end. And the reason for this is it's probably big enough, and it's got kind of an independent UI, but the challenge is that it cross-cuts a huge amount of business domains, which means you'd have loads of different teams constantly trying to make changes to it and just sort of falling over each other. And this is probably more appropriate to try and solve this using kind of a collection of APIs. So I just want to finish off by talking about how we're improving. And this is, I've got to admit, a little bit of a sales pitch on how great we're finding micro front ends. So basically, it's making us faster, happier, and better. Which sounds pretty great, right? Faster in the sense that teams are only having to test and build small independent applications. And we've got a massively reduced need for cross-team interaction. So we've got much easier feature delivery. Happier. If you give developers control of technology and control of feature delivery, they're going to be happier. And as a result, you're going to find it easier to hire because that kind of happiness just comes across in the interviewing process. On top of that, those small code bases make it easier to refactor, easier to test, and it also makes it easier to validate changes with things like A/B testing. And finally, better. Smaller, more regular releases mean rollbacks are less impactful and error rate is lower. And by having teams working on a particular area, they start to develop really strong domain expertise and understand what the clients want, which means when they're delivering features, they can deliver them that are much closer and much more suited to the client experience. So we've certainly found micro front ends brilliant. IG, we're really excited about where they're leading our enterprise, but we certainly don't know everything there is to know about them, and we'd love to get feedback and get people's thoughts. So please do get in touch. And everyone likes a shameless plug at the end, right? All the code's available on my GitHub. Come and follow me on Twitter. I do occasionally tweet interesting things. And if you have any questions that can't solve on GitHub and doesn't seem to be on my Twitter, you can always email me there as well. And that's it. That's all I've got.